we are going to look at different questions that made most of the IGCSE 0625 October-November 2025 to cry. So we are going to discuss and get to see what were they supposed to understand for them to be able to get the marks right. And from there, you can also be able to learn what you are supposed to do so that this coming exam, you will be able to crash physics, to crash 0625 paper 4 with lots of ease. If you're new to Prof Learn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. In this particular video, we are going to base our discussion on the areas that were tested in October-November 2025. If you are new here, you can also join our Patreon page so that you can be able to see what I usually post there. So let's dive in so that we can be able to see what are these questions that made most of the candidates to cry. Some of the candidates cried when they saw a question that was asking them to differentiate between velocity and the speed, velocity of a train and the speed of a train. So students failed to understand that velocity is a vector quantity while speed is a scalar quantity. So candidates were supposed to understand that vector quantities are those quantities which have both size and direction. They have both magnitude and direction. While scalar quantities, they only have size, they only have magnitude, but no direction. So in the event students were to understand that, then they could be able to go straight and so that they can be able to work out questions and avoid to cry. So what was the expected of them? What were candidates expected to say whenever they were given this question? They were supposed to say that speed is a scalar quantity while velocity is a vector quantity because velocity has both size and direction. Another candidate could have said velocity is speed in a particular direction so that they can be able to differentiate between the two. Other students got difficult and challenges in answering the question to do with kinetic energy of the moving train. From the question that we were given here, we were told that the train has a mass of 440,000 kilograms and it was moving at a constant velocity of 56 meters per second. So candidates were supposed to have remembered that kinetic energy is equals to a half mass times velocity squared. And then if you can substitute that in your calculator right now so that you can avoid crying in this coming exam, you are going to get your answer 6.9 times 10 raised to the power 8 joules. Candidates cried, missing marks on units. So whenever you're going to answer this particular exam, remember, if the units are not well written here, you have to ensure that you are going to write those units so that you can be able to earn all the marks. Otherwise, if you fail to do that, you're going to lose a mark, and then that will end in tears. In question C, we are told that the train has a uniform deceleration, meaning that there was a braking force. And students were calculated to calculate now this braking force, to calculate the force. Now, candidates cried, not knowing that force is equals to ma, mass times acceleration. But the acceleration that was provided here was a deceleration, so meaning it was slowing down. So candidates were supposed to use force is equals to ma, and upon doing that, the force will be 5.3 times 10 raised to the power 5 newtons. Then calculate now the distance traveled. This is the question that made most students in the whole world to cry. Because they could not understand that they can be able to relate this energy they have gotten here as the energy that is being supplied, or that the energy that is available, then force is doing work to overcome this or to slow down this object. So meaning that the force that was applied did work to stop this moving object, then meaning that the kinetic energy is equivalent to the work done by the force. So which means that we were to use work equals to force times distance. The force already we have it here, and the work is energy, which is 6.9 times 10 raised to the power 8. Then if you use that here, you will get your answer as being 1.3 times 10 raised to the power 3 meters. So this is quite one of the questions that was that really ended badly in the exam. Question number 2 contains about information about planet mass, and student was supposed to remember that weight is equal to mass times gravity, and if you make G subject here, you will have weight over mass. And but remember, weight is a type of force. So if you are to define gravitational field strength, which is G, you will say gravitational field strength is force per unit mass. Force per unit mass. And then you need to know also how to use this formula to calculate mass, to calculate weight, and so on. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. All right. An object of weight 4.2 newtons at the surface of Earth. Meaning that we can be able to get the mass on Earth. Okay. Now calculate the weight of the object in mass. So what we needed to understand there is that mass is constant everywhere. While you are on Earth, while you are in another planet, in the moon, mass is constant. Yeah, but weight depends on the gravitational field strength of a place, so it varies from one planet to another. So the first section of 42 newtons on Earth was meant for the candidates to be able to find what? To be able to find the mass. And that mass is the one that is going to be transferred to planet mass. Then that's going to be weight, mass is equal to weight over gravity. Gravity on Earth is 9.8, and always check this value at the first page so that you can be able to exactly know whether you are using 9.8. Most of the time you are using 9.8, whether you are using 10, so who knows. So always check the first page, you know what was the gravity, and this is 4.29. Then this is now the mass in kilograms. This is the mass in kilograms. So meaning that I'm going to write here in kgs, mass in kgs. And for us to work out weight, we're going to say weight is mass times gravity. But for planet mass, gravity is 3.7 Newton per kilogram. So that's what we're going to use here, 4.29 times that, and that's going to be 15.8 newtons. And then calculate the volume of mass. Candidates were supposed to remember that density is mass over volume. This coming exam, you must have a question to do with density, but you need to understand the formula, then you use the information that is provided for you to earn those marks. Then the triangle formula for this is mass, density is mass over volume. Then mass should be density times volume. So, but volume will be mass over density. So, which means that this question is asking the volume of mass. We are going to check what was the mass of planet mass. 6.4 times 10 to the power 3. What was the average density of planet mass? Was 3900. Then we are supposed to say mass over density, and that's going to truncate to, or it becomes 1.64 times 10 raised to power 20, and this is going to be the units meter cubic. So some student cried in the exam room because they never included the units, and some marks were deducted. So to avoid such kind of accidents, to avoid such kind of terrible accidents, you need to ensure that you remember to include the units of the quantities that you have found, so that you can be able to earn all your marks. Otherwise, it will end in tears. All right, so let's move to part C. Let's move to part C. And part C requires you to add a force on the diagram to show the resistive force. Remember, resistive force is a force that opposes motion of an object. But since we were told here that the buggy is moving at a constant speed. So if it's moving at a constant speed, it means the resultant force is 0, meaning the forward force is equal to the backward force. So when you are to draw this arrow behind here, you have to ensure that it's acting backwards and it's of the same length as this, so that they are balanced, the forces are balanced. And when the forces are balanced, they are acting in the opposite direction, it means the resultant force is going to be what? Is going to be 0. And then that object is going to move at a constant speed or constant velocity. Then state the effect. Remember, we are told that air resistance in mass, this was on Earth, but in mass, air resistance is less. So if this force is going to remain the same, then the resistive force is going to be less. While in mass, right now it's on Earth, the forces are balanced, 30, 30. Resistive force is 30. But when this bag is going to be placed on Mars, so that it can be able to do the analysis and send the information to the scientists on Earth, so that we can be able to analyze what's happening in that planet, then we are told that the resistive force is less, which means that if the driving force is going to remain 30, then the resistive force is going to be less than 30, then it means there will be a resultant force forward. So we're going to say this will result to an increase in the resultant force, and this is going to make this bag to move, accelerate forward, because there's a forward resultant force. It states the relationship between resistive force, driving force, and resultant force. So resistive force acts backward, driving force acts forward. To find the resultant force, it will be driving force minus the resistive force. And that is exactly what you're going to do in that particular question. The next question that was tested is about thermal energy transfers. Describe the energy transfer that acts on the solar cell. These are the electromagnetic radiations from the sun are converted to electrical energy by the solar cells. So electromagnetic radiation, visible light, is converted to electrical energy as shown there. Suggest how the black coating allowed the solar cell to transfer more energy. So something that candidates were being tested here, do they understand that thermal energy, do they understand that black surfaces are good absorbers and white surfaces are good reflectors? So if black surface is a good absorber, it means more radiation will be absorbed and then they will be converted to electrical energy. So that is the purpose for this. Black surfaces are good absorbers of radiations. And further, we are told that 0.72 kilowatts of light is incident on the solar cell. This is the incoming, the input. And then we are told the efficiency is basically 75%. Calculate the output power. So candidates were supposed to remember efficiency is equal to output over input times 100. So the output is X, efficiency is 75%. So meaning this equals to X over 0.72, which is the input, the radiation that are coming in is 0.72, and then times 100. But if you work it out, you are going to get the output is going to be 0.54 kilowatts. Kilowatts. Yeah, kilowatts. K in physics means 1000. So that's something also you had to remember. So so that we can be able to proceed to the next part, we shall now let's move down so that we can be able to see what else the candidates asked to respond to this. State the meaning of the term kilowatt hour. State the meaning of the term kilowatt hour. And most students really find challenge answering this question. We are going to say here, this is the energy transferred in 1 hour. 1 kilowatt hour is the energy transferred in 1 hour at the rate of 1 kilowatt. Is the energy transferred in 1 hour at the rate of 1 kilowatt? Yes. All you can say is the amount of energy transferred by 1 kilowatt appliance in 1 hour. So it's you to decide how you can structure your answer for this particular question, and be very sure this is a question that most candidates are not really getting right. And for the last 3 years, I've seen Cambridge repeating this question. So who knows that this question might be asked. So ensure you get ready, and you get ready to answer such kind of a question. Energy is produced by each solar cell for an average of 6 hours per day. A household uses approximately 74 kilowatt-hour electrical energy per 1 year. So, calculate the number of solar cells needed to produce energy for one household. Give your answer as a whole number. So, but here, something that is very, very clear is that each solar cell produce energy for 6 hours in 1 day. So, meaning that this is going to be per day, yeah? Average of 6 hours per day. Okay, and from the previous question here, we have worked out the efficiency of one cell. So which means that in 6 hours is going to produce in 1 year is going to produce 0.54 times 6, because it's going to work for 6 hours, times 365 days, that is for 1 year. Then you are going to get 1182. Then you take that 1182, divide by the value that we have at that given point, and that is going to translate what? 6.26, which is approximately 7 solar cells that will be able to serve the household. Yeah, so basically that's what you are supposed to do there. In question number 4, the question was about specific heat capacity, and candidates were supposed to remember that specific capacity times mass times temperature change is equal to the thermal energy that is absorbed by the water. But remember, the solar heater supplies the heat, but water absorbs that heat. And thermal energy absorbed is E is equals to mass times specific capacity times temperature change. How do you get temperature change? It will be 58 minus 20. The temperature change is 38 here. And the question was having the mass of 0.15. And then if you work it out, you're going to get 24,000 joules of what? Thermal energy was supplied. And once that is well understood, we can now look at part B, which also a kind of a question that made most of the students to cry, but it was quite straightforward because we have a metal rod and we have a plastic rod. What's common between these? These are solids. So meaning thermal energy is going to be transferred by conduction. So if thermal energy is going to be transferred by conduction, but one is a poor conductor, the other is a good conductor, then candidates were supposed to explain how is the temperature at point X going to vary at point X. This was point X. Is the same distance from this for both of them. How is temperature going to vary? So we're going to say for the metal rod, the temperature here will increase at a greater rate. Temperature in X for the metal rod is going to increase faster because the metal rod is a good conductor. It has free delocalized electrons which are going to transfer thermal energy quite fast. But for the plastic rod, temperature will increase slowly because it's a poor conductor. Please guys, do you think this question was so easy? But most students decided to complicate it and they ended up crying out of the classroom. So they needed to understand different conductors have different conductivity. Some are good conductors like metals because they have free electrons which transfer energy, and plastic rods are poor conductors, or wooden rods are poor conductors. So what were candidates supposed to write there? Plastic rod and metal rods are solids, and thermal energy will be transferred through conduction. It's going to be transferred through conduction. The metal is a good conductor because it has free electrons. So temperature at X will increase faster for the metal rod compared to the point X in the plastic rod. So that's how you are supposed to explain yourself so that you can be able to earn a whooping 4 marks for that particular question. Question number 5 was talking about sound. Some of the few things that you need to understand: sound is a wave, but this sound is a longitudinal wave because the particles vibrate parallel to the direction of the wave travel. Number 2, you need to understand a few concepts like how fast is sound traveling in air, how sound travels in solids and liquids. Sound in air travels at the rate or at the speed of 340 to between 330 to 360, around there. Yeah, you can give 340, you can give 341, you can get 350, and you earn your marks. Then in water is a liquid. Speed is approximately 1,500, averagely around 1,500. So meaning that speed is going to be higher in water. But for solids, speed is around 5,000 because particles are closely packed and then they are going to be transferring the wave energy faster. But for air, particles are far apart, so it takes time for the vibration to travel for air. Then you earn your marks. Then we look at a situation whereby students were asked about the human hearing range. So candidates were supposed to remember that the human hearing range is basically the human hearing range. Students were supposed to remember that the human hearing range is approximately 20 to 20,000 hertz. So candidates were to remember that the human hearing range, what we can a normal person can perceive is a sound of frequency between 20 and 20,000 hertz, and anything below 20,000 hertz, anything below 20 hertz is called infrasound. So infrasonic sound, you cannot be able to hear it. Anything above 20,000, that is ultrasonic sound, you cannot hear it. So, but in this case, we were told that the dolphin produces sound in the range of 7 to 15 kilohertz. So what does this mean? This means 7,000 to 15,000 hertz. That's what this statement meant. Then meaning that if the human hearing range is between 20 to 20,000 hertz, then it means 7,000 to 15,000 is within the human hearing range, then meaning that the human being is going to hear all sounds, all sounds that are produced by the dolphins. So we are asked, state and explain if the human with normal hearing can hear all the sound emitted. Yes, he's going to hear that because the sound produced by dolphin is within the human hearing range, and that is exactly what you are supposed to say there. Something else that candidates were supposed to remember is that amplitude affect the loudness of sound, and pitch is affected by the frequency of sound. So which means that if the amplitude is large, then the sound is going to be loud. Because if you hit a drum with a greater force, it's going to vibrate with a very higher amplitude, and in the process is going to produce a very, very, very loud sound because the amplitude is large. And then so if the amplitude is large, it's loud, and if the amplitude is small, is a quiet sound or a soft sound, ambient soft sound. And if the frequency is high, this is going to be sound of a high pitch, but if the frequency is low, it's going to be a sound of low pitch, high pitch, and this is going to be low pitch. So also we're going to look at vibration. Particles vibrate to produce compressions and rarefactions. So you needed to remember that compressions are regions of high pressure, and the rarefactions are regions of low pressure. Diagrammatically, you'll be able to see. I remember maybe you can be able to remember these kind of diagrams that I like this. Then we have this ones here. Then we have some closed here. Then some space like that. So this region where the wavefronts are very close is called compressions. This is compressions. But this region here where there's space is called rarefaction. And rarefaction is a region of low pressure, compression is a region of high pressure. And here particles are vibrating very fast, high kinetic energy, so you need to remember that. And something also I need to mention, maybe they can ask you to find the wavelength. You need to check the middle of a compression and the middle of the next compression. So this distance represents the wavelength. It represents the wavelength. Or you can take middle of a rarefaction and the middle of the next rarefactions, so that you can be able to tell that. Then we have an optical fiber. This is fiber optics, the fiber optics or optical fiber. A light was directed, then light is going to be undergoing total internal reflection like that, and as it's going to travel through the optical fiber. And this is the angle of incidence. Angle of reflection is going to be the other one here, whereby we have a normal. Remember also, condition for total internal reflection is that the ray of light must be traveling from higher optical dense medium to less optical less dense medium to a less optical dense medium. And also the angle of incidence in the dense medium must be larger than the critical angle. Those conditions are very, very key. Advantages of using optical fibers is an area that made some students to be flabbergasted, and then they were supposed to remember that faster transmission of data, and also can accommodate large amount of data. This can accommodate a large amount of data. Calculate the critical angle. Candidates were supposed to remember that sine of C is equals to 1 over the refractive index, this particular formula here. In order to earn the marks, candidates were supposed to remember that sine C is equals to 1 over n, then apply it, find the sine inverse, and get the marks for that case. State the meaning of critical angle is also a question that is usually asked. Is the angle of incidence in the dense medium. This is glass, which is dense, and this is air, which is less dense. So is the angle of incidence in the less dense medium, which is the critical angle, when the angle of refraction is 90 degrees. Then we're going to say angle of incidence in the dense medium when the angle of refraction in the less dense medium is equals to 90 degrees. Up to that point, we have just covered most of the questions that made students cry in this exam. You can be able to check a link in the description below, so that you can be able to access the second part of this tutorial that made most students cry. Now from here, most students cried. So there was electricity that made students cry. I can be able to see here, yeah, electricity really made most students cry. And then we have electromagnetic induction that usually make most students to cry. Is also another area that was tested, how a bell works. And then there was also the concept of space physics that also made most students cry. So can you check the link in the description so that you can be able to see if you were in that particular exam, October, November 2025, could you have cried for this next section? And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. We shall have a journey even to up to A levels. Guys, if you are new here, consider subscribing, and also remember to share this video to your friends so that they don't cry. So that they don't cry. Please remember to share this video to your friends so that also they don't cry in the upcoming exam. Guys, see you in the next tutorial. Check the link in the description for the set of questions that made candidates to cry.